Right.
Okay, so then we're all set. Seems like. Thank you. Sorry for the.
All right.
Okay, so then. Yes, thank you. Sorry. That was the previous link that was not working.
That's the way it goes.
Okay, so this week preparation was something very interesting. Was different, using different formulas in the margin error.
Yeah, it was lots of fun.
Okay, so are you ready to go over the material?
I'm ready. Do it.
Okay. So now for part 2, number 6, it says, what are the 3 assumptions that need to be checked before you compute a confidence interval for a mean? I got a simple random sample was drawn from the population. The distribution of the sample mean is normally distributed, and the sigma is assumed to be known.
Yep, that's what I got also.
I shorthanded those answers, but yes.
Okay. The next one, it's given us a paragraph to go through. It says the graduate management admission test is used as an admission criterion in many Masters of Business Administration programs. A BYU Idaho professor would like to estimate the population mean from a random sample of 50 people's scores. The sample mean for these 50 students, it's 541, assuming a population standard deviation of 32. Answered the following questions. So number 7 is, what is the point estimate for the population mean?
I just got the 541.
Yes.
Correct. That's what I
then
got.
It says number. Thank you. So then it says for number 8, create a 95% confidence interval for the population mean. Show all your work below. So in this one, we needed to use the formula.
Mm-hmm.
And I came up with a margin within 532.130 and 549.870.
That's what I got also.
Yep.
Okay. Yes, because we needed the minus 1.960 and then times 32 divided by the square root of 50.
Yep.
Okay. Number 9, it says, say that the sample size changes to n equal 100, compute a 95% confidence interval with the same point estimate.
So that one I got 534.73 and 547.27.
Yes. Correct, that's what I have. Is it what you got, Sean?
Yes.
Okay, wonderful. Then it says number 10, how does the margin of error for the 95% confidence interval of sample size 50 compared to the margin of error for the 95% confidence interval of sample size 100?
The margin of error gets smaller when your sample size gets bigger.
That's true. Number 11, it's create a 90% confidence interval for the original 50 students.
So I got 533.56 and 548.44.
Same for me.
Are we supposed to go 3 decimal points? I think when I was checking the answers, they went 3, but I probably should have done 3.
I did 3.
Yeah, I'll have to make sure to change that when I do it.
Okay. So then number 12 says, how does the margin of error for the 95% confidence interval that you computed in question 8 compared to the margin of error for the 90% confidence interval that you computed in question 11?
Yeah, I thought it gets smaller with that one also.
Yes, it is smaller as the confidence is smaller as well.
Mhm.
And the very last one says the BYU Idaho professor would like to repeat the experiment, but he wants to make sure that he has enough students in his sample to ensure that his margin of error is 5. How many students will need to be in his sample to ensure he has this level of accuracy for a 95% confidence interval?
So I didn't finish calculating that one out. I just barely got the equation written down. But you calculate.
Yes. Yes, I got 158. So the formula was n equal to the interval, which is 1.960 multiplied by 32 divided by 5, which is all of
Then you gotta
that.
square all that, right?
Yes, all that in parentheses to the second power, to the square.
Yes, so I think that ended up being like 157.35 something. And
Yes.
then so you got to round up to the 158.
Correct, because it's asking you specifically for amount of people, so we cannot have a fraction.
So it's 1.96 minus 32, right?
It's multiplied the deviation, which is 32.
That's why I'm not getting the numbers correct. It's multiplication. All right.
And then divided by the margin of error, which is 5. All of that to the square.
Okay, that makes sense now.
Yes, for me, this one was very straightforward, just using the formulas. I think it comes hard whenever we need to interpret the information.
Yeah.
So what did you guys get for an answer for that one?
158.
See, because I get 157.35.
Yeah,
Correct.
That's what I got also. And then since it's asking for people, you can't have 0.35 people, so you round up to 158.
Yes.
Okay. Alrighty. Said I had it written down. I just had my formula. I forgot to multiply. I was using a subtraction and it just wasn't working.
Oh yeah, I know all these formulas look really similar, and so it's hard to
right
all straight.
Yes, it's just different ways to solve for each item that we need to find.
Right.
Okay. So do you have any other question in regards to any question on the preparation part 1 or part 2?
I don't. For me, it's just making sure that I get the numbers written down whenever I do math. I always mess something up.
No worries.
Yep, that's the important thing. You can make sure we get the right numbers in the right spots.
Certainly. Okay, so then are you ready for the quiz?
I say let's do it.
Sorry, Sean, did you say something?
Yeah, I'm ready. I'm ready.
Okay, let's go ahead and start it. True.
Have you guys been watching the supplemental videos?
I haven't. I don't know. I feel like I haven't had time.
Spent the time doing that, but that's 12 to 15 minutes a night. That's really helped me understand it.
Really? I know. I really should try to fit that in.
Yes, whenever I'm not clear in a problem, I just go to the tutorial section for that specific problem and check that out to get an idea, and it's helping me.
Are you guys having an issue getting this quiz to load? I can't get it to load.
Mine loaded.
No, mine it's loaded already.
Yeah, it just tried to tell me in group meeting. Yeah, it's not. All right, so
You can close it and pull it up again and check. So it's not coming up as part of your topics then?
Yep, I got it. I got it this time.
Okay.
Okay. All righty.
Okay, so it says question 3. Find a margin of error for a 90% confidence interval when the standard deviation is 50 and the sample it's 25. Round to 3 decimal places.
Need to get some scratch paper here. Sorry. I'm a little off sorts today. Like I said, it's been a busy last couple days.
Oh, no.
Certainly, it's been
hard,
very busy.
It's hard coming off another meeting too, when your mind's kind of focused on that and you got to shift gears.
Yep. So 90% confidence interval when the standard deviation is 50 and n is 25. So 90 is margin of error. So that's m equals 2 times the standard deviation, which is 50, divided by the square root of n, which is 25. Did I set that up correctly?
Where did you get the 2?
Well, I was just looking. I'm sorry, I'm in the wrong spot here. I was looking at. That's the margin of error formula that was there.
Yes, we need to not to round it to 2, but instead of 2, using 1.645.
Right. So it's going to be.
Then using that, we have 1.645 multiplied by 50 divided by the square root of 25.
Right. That's how I figured it.
1.645 times what now?
50 divided by the square root of 25.
Right.
I am getting 16.45. Is it what you're getting?
That's what I got also, yeah.
This is a big number.
16.4?
45.
Yeah, so it sits around 3 decimal places. So I threw a 0 at the end. 16.450.
That's what I'm doing. 16.450.
Okay, so I'm just trying to make sure that I got this one correctly.
Okay.
This formula came from, it's going to be plus or minus the 16.450, correct?
Correct.
Okay. Yes.
All right. Just want to make sure I was. Okay. All right.
Okay. So then number 4 says, which of the following statement is true? Standard deviation to the square is an interval estimator of x. X is a point estimator of mu. Mu is a point estimator of x. And standard deviation is an interval estimator of standard deviation to the square.
Did we talk about interval estimator? I'm trying to remember what those are.
What's that?
That interval estimator
is a range of plausible values for a parameter.
Oh, okay. That's right.
Let's check.
So the x is a point estimator of mu, isn't it? Isn't that?
I'm not sure with this one. Point estimators. It's x2. Yes, it's x to mu. X is a point estimator of mu.
Right.
Yes, because the other ones are not in the chart that I am seeing from the written.
Right.
Yeah, it has like
Yes, it's just x. Yes, x is a point estimator of mu.
Okay, that's what I think it is. So the second one down.
Yes. Then it says information. Gina wants to construct a 95% confidence interval for GMAT scores. She knows the standard deviation it's 113. She collected a simple random sample of Xi 64 and computes x equal to 526. Uses information for the next 6 questions. And so that's the first one. What is the point estimate for the true GMAT score?
Point estimator is going to be 526, isn't it?
Yeah, that's what I
Yes.
was just thinking. 526.
Next. That's it's 5. And it says, what is the margin of error for the 95% confidence interval for the true GMAT score? If it's 95% margin of error, it will be 1.960 multiplied by the sample, which is 64, divided by the square root. Oh, sorry, no, it's the standard deviation. Sorry, it's 113.
So is it
divided by
526 plus or minus the 1.96? That's the formula we're using on this one, if I understand it correctly, right?
For the margin of error, it should be, I believe, the 1.96 times the 113 over the square root of 64.
Yes, it's just the margin of error that we're calculating right now.
Why do I keep messing that one up?
It's 113 divided 8 times 1.960. I'm getting 27.685. Is that what you're getting?
That's what I ended up with, yes.
Let's do it one more time. 64, it's 813 divided 8 times 1.960. Yes, 27.685.
113 divided by 64 square root times 96 equals 27.685.
Yes.
This is for okay.
Okay, next one says, what is the lower limit of this confidence interval? So in this, yes, we will be using the 526 minus. That's the other formula, correct?
Yeah, I
It's
believe so. So we do the 526 minus what we just figured, the
27.685. So it will be 498.315.
That's what I got, yep.
$498.315.
Yes, because we're subtracting now.
So I guess it's going to help my brain. Excuse me.
Bless you.
To think about this one here is that I don't necessarily need to do the long formula every single time. I need to be able to take whichever the z-score is going to be for the 90, the 95, and the 99, and then times that by the standard deviation divided by the square root of whatever n is, and then that's your plus or minus. You don't have to plug that big long one in every single time.
Correct.
Yeah, once you
Because
got-
if you find out before the margin of error will be better, you will be summarizing the long formula by having x minus the margin of error.
Yep.
And then, yes.
Yeah, they kind of marked it as an M in the reading. So once you
Yep.
have the margin of error, then they just plug M in for that.
That's good. I like that.
Simplifying it. So then for number 8, it says, what is the upper limit of this confidence interval? I got 553.685.
Yep, that's what I got.
Yep.
Okay, so then it says, what would happen to the width of the confidence interval if you increase the sample size?
That would decrease it.
Yes. It will decrease.
Hold on a
Then
second.
it says, what would... Okay.
Increase. I'm just making sure, going back and double checking my math.
Yep,
So,
no worries.
Sure.
685 plus 553.685, and then yes, it increases. Right. Width of the confidence interval increases with sample size. Let's see here. Right.
No, for number 9, it's not to decrease. What would happen to the width for the confidence interval if you increase the sample size? It will decrease it, right?
So 9, it was increased, and 10, it's asking what
Mhm.
would
I thought
happen if it goes to 99%.
I thought it decreased if you had a larger sample size.
Yes.
So
Yes.
9 is decreased.
Yes, 9, I think it's decreasing because we're having a larger sample size. So the margin of error will get smaller. So it will decrease.
Right. That's how I understood it.
Correct. That's what I got.
Mm-hmm. Okay, so then number 10, it says, what would happen to the width of the confidence interval if you change to a 99% confidence interval?
So on that one, it would increase if we're raising the confidence interval.
Correct.
Are we? I'm sorry, guys. I'm out of it. Are we on 9 or 10 now?
10.
So 9, yeah, 9 was decrease. 10, I believe, should be increase.
Yes.
Yes. Okay.
Mm-hmm. Okay, so you got 10 to increase, Sean?
Yes.
Okay, thank you. So the number 11, it says, bright bulb light bulb companies planning a study to assess the average life expectancy of their light bulbs. They know the standard deviation, it's 400 hours. They want a 95% confidence interval with a margin of error of 50 hours. What sample size do they need? Round up to the nearest whole number. Example if it had blah, blah, blah. Okay. So then this is the formula we used, which is n equal to the interval. In this case, it's 95% multiplied by the standard deviation, which is 400, divided by the margin of error, which is 50.
Yeah.
And the 95 interval is 1.960.
Then we got to square that whole thing.
Yes. Then to the square.
So that's n equals 1.96 times standard deviation is 400, correct?
Correct.
Divide that by, which one was that?
The margin of error, which is 50.
Okay, there it is. Margin of error is 50. Square it all. Okay.
Yes. I am getting 246 already been rounded.
Yeah, I got 246 also.
245.86 rounded to 246.
Right.
Correct.
I can tell I'm going to have to go back and review this one.
Okay.
Okay.
Okay. Then it says information for the next one. The mean salary of actuaries it's mu equal to $100,000 and the standard deviation it's 36,730. You are interested to know if the mean salary for women actuaries is different from the population mean, but are not sure if it is higher or lower. You send up a hypothesis test with level of significance alpha equal 0.05. And the null hypothesis 100,000 and alternative 100,000. You collect a simple random sample of n equal 36 women's salaries and find that x equal to 111,000. And it says use information for the next three questions. What is the lower limit of this 95% confidence interval? Then first we need to find the margin of error then.
So margin of error. Because we're looking at 95. So it's 1.96, correct?
Yes.
Times
36,730, which is the standard deviation, divided by the square root of 36, which is the sample.
So standard deviation once again was 36,730. Is that correct?
Yes.
Divide by the square root of 36. Just trying to make sure I'm doing this correct. I came up with 11998.466.
That's what I got also.
At 11,998.467, right?
Mm-hmm.
So then this is the margin of error, and then mu it's 100,000. So we need to subtract this amount from $100,000. So it will be the lower limit. I am getting $88,001.53.
What did you get? You got
$88,001.533.
I got 99. Because do we use the X, the 111,000?
Do we need to use? Also, yes, sorry, I was using the 100,000. Yes, you're right.
So you take the 111,000 and you subtract the margin of error, correct?
Yes.
Right. Of our new sample mean.
Correct.
And then you subtract.
Yeah, so it is 99,001.533. Right.
It says to round to the nearest whole number, so that'd be 99002, right?
Yes. 99002. There you go. And it's asking for the upper limit. Plus On the upper limit, I am getting 122,999.
Yep, that's what I got also.
122,998.
999.
Or do we round it down, or do we round it up?
How
would
would you,
round to the nearest
why-
whole number?
yeah? Why would you round it? There's no sense after that. So the 8 is a whole number.
Okay,
Oh,
so
wait a minute. I see what I
But yeah, I
forgot
would
to do.
think we.
My bad. I forget. I see what I forgot to do. Let me try this again.
Yes, because we need the 0.467
To round it to
the up number. Yes, 999.
So do we round it up, even though it's a 4?
Yes,
This isn't
because
like the,
I am rounding it to 999 because it is the same as the exercise and the preparation. If we would like to come up with all of the previous math, we need to steal the 0.467 from this calculation.
okay. So 999.
That's what I am thinking.
okay. 1, 2, 2. My brain is about ready to fly.
And then last one says there are 3 requirements that need to be checked when computing a confidence interval. They are simple random sample, segment known, and it's all of the above.
Yep, all of the above.
Okay, let's check how it goes.
Yep. Alrighty.
Okay, we got them all. Nice.
Alrighty. Good job, gentlemen.
Yes, so we're all done then.
Good
Thank
deal.
you for
All
being
right.
Okay, so then we're planning for next Thursday then.
I don't think I'll have
normal time.
Thursday. It should be the normal regular time.
Okay,
Yeah.
that sounds
A
good.
little bit regular. But thank you. I appreciate that you were willing to move this out. Thank you.
You bet.
Okay, so then see you on Thursday then.
All right. Good
All
night.
right, sounds good. Thanks, guys.